Greetings, Geekbeard here, and welcome to Demonic Diaries episode 4, here in which I recite some and analyze some certain secret writings that I've discovered. So without further ado, let's jump in. This is file number 1. Must I give over to my algebraic side? For me, that's what this writing amounts to. Must I give over to my algebraic side? Of course, we kind of have two sides, algebra and geometry. And they're very different but complementary. I'll keep reading. Bicamerality. Writing is hard because the left brain is authoritarian and demands solutions. But subtle writing must be more than that. Well, bicamerality means the difference between the left and right halves of the brain, which is a very interesting and deep kind of subject. I mentioned in another video that I read about 6 months ago now, a really good book about bicamerality by a guy called Ian McGilchrist. And I definitely recommend you Google him and maybe check out some of the interviews and YouTube videos with him in it, because he has some really, really good and interesting ideas. The book was called The Master and His Emissary, I think. And it's a little bit long. It's like 700 pages or something. I enjoyed probably the first half, well, the first third or so, and then the end third or so. But in the middle, he gets stuck into talking about his favorite philosophers, which doesn't feel terribly relevant to the subject, seeing as most of these philosophers didn't have anything to say about the bicamerality of the brain and probably weren't even aware of it. Subtle writing must be more than that. In other words, more than authoritarian solution demanding of the left brain. Yes, the left brain very much likes symbolic kind of reasoning, where everything is sort of reduced to something known and contained, very much like algebra in some sense, I would say. Geometry involves more sort of processing of full complex visual scenes, and for that reason I would suggest it's more right brain. We know for a fact that language is definitely concentrated in the left brain. So it feels as if visual intelligence should be logically more concentrated in the right brain. The main separation that McGilchrist makes is he believes the two halves of the brain have evolved for two different types of intelligence, and the left brain is very focused and very detail-oriented, very oriented towards smaller things, and is used for manipulation of things. It's very much focused on how do you move your hand towards something on the ground, like a piece of fruit, and grab it and do something with it. Conversely, the right brain, and yes, and also the left brain is connected to the right eye, and vice versa. The right brain is connected to the left eye. And he argues that the two eyes actually perform separate roles as well, even in animals, because animals also have this separation of the brain, the left versus right. Although I should emphasize at this point that the left and right brain are not separate. They're actually very heavily connected as well through a connection called the corpus callosum. But, to a degree they are separate, and they think in different ways. So he claims that the right eye is very focused and very manipulation oriented. So it's sort of focused on things that are smaller than yourself. So you're scanning the environment looking for fruits or things that you can eat or otherwise manipulate. That's what animals are using it for primarily, and of course we have similarities to that as well. The right brain, he claims, is more kind of on the lookout for predators or other emergent phenomena that might pose a threat. So the right brain is thinking about things that are actually larger than you and trying to observe when there's any kind of change or any kind of danger in the environment, basically. And of course, the right brain is connected to the left eye, remember? So he believes, and I think he provides evidence, he has evidence to the effect that the right eye attached to the left brain is doing all the very focused kind of work, finding things you can grab and manipulate and eat. And the left eye is kind of scanning the environment and is on the lookout for anything larger than you that can threaten you in any way. Predators being the most important example. And then he claims, the further features of left and right brain have kind of evolved from there. Writing is hard because the left brain is authoritarian and demands solutions. But subtle writing must be more than that. In other words, it must incorporate the right brain to a degree. That I should find it so hard. Does it imply that my left brain is flawed? But when was I really good at it? Ever? Only occasionally, only when I was forced to. Change the subject. There's nothing sexy about fast Fourier transforms. All this completeness. Who cares? It's deep, man. It's deep. Why am I arguing with myself over whether I should write a certain thing or not? Okay, next file. Cat 1 says, maybe the strong Zipf hypothesis can give you some inspiration. You know, the one where alpha converges to 1? I don't know how many of you have heard of the Zipf hypothesis, but it's basically a power law which supposedly occurs very often in real population distributions. And it's basically just a hyperbola or an inverse law of 1 over x, which is mysterious in its own right because that's not a proper probability distribution because it cannot be integrated. The integral of 1 over x is just log, and the integral all the way to infinity is therefore infinity. And you can't cut it off at the leftmost point anywhere and get anything other than infinity either, because it's still a log. If you integrate 1 over x to the alpha, and alpha is greater than 1, then you can integrate it from something greater than 0 to infinity, and you'll get something non-infinite. And those distributions are sometimes used, and they're called Pareto distributions, usually, I think. Whereas Zipf distributions, I think, is usually the name given to the discrete versions of those same distributions. Or maybe that's the zeta distribution. Yeah, that would be. But I think Zipf is sometimes included. So, I invented something called the strong Zipf hypothesis, which says that under circumstances of relative stability, population statistics will have a 1 over x to the alpha distribution, but that alpha will gradually converge downwards to 1. It's kind of strange because alpha equals 1 is not a proper distribution, and yet either in the continuous case or in the discrete case, because zeta of 1 is infinity. And yet populations just naturally seem to want to converge to this distribution that doesn't quite make sense. Sort of begs the question of what are we doing? Why do we seem to almost desire instability? I'll keep reading. It somehow pertains to the reflexivity of awareness, the Zipf hypothesis this is, both informationally, and here's the really weird part, geometrically. Put that in your pipe and smoke it, devil machine. Not even I know what I'm talking about at this point. Cat 1 says, but you get the point, right? Your viewers see you, see your viewers, see you, see your viewers. LLO says, it's a never-ending clusterfuck. Cat 1 responds, of goodness. LLO says, but what do I do? How does that inspire me? Cat 1 replies, your work will resonate on all scales of reality or dimensions. Take your pick. LLO says, or octaves. Cat 1 responds, no, that's just silly. LLO says, in my head, I like to over-contemplate things. Cat 1 responds, I think you meant overcomplicate. I enjoy that too. And now I think we're just back to the narrator. Mysterious complexities are places that feel like we can put the solutions that we don't really want to find after all. Because what's the fun in that? Reducing beautiful obscurities to formulae? No thanks. Well, Fermat's last theorem is a beautiful obscurity. And I solved that, but I'm not going to tell you the solution. Let it hereby be acknowledged that this is a sacred document protected by the power of the Fermat hexagon. Bind. LLO says, and then I have to describe the factorization structure of fast Gauss sums. Ugh, whatever that even is. Cat 1 just says, well, they obviously have factorization structure, just like FFTs obviously do, just no one writes it that way. I'm hoping I can simplify stuff with actual substitutions or something. I mean, can you, say, convert a matrix to a power series that way, at least? Well, that's getting into some maths that in the 2 years since I wrote that, I still haven't made any progress on. But I was basically trying to write fast Fourier transforms as a kind of matrix tensor product. To be precise, you can sort of factor some transforms, like the fast Hadamard transform can be factored as a certain thing I call a flat tensor product, which I invented. Because no such thing previously existed, and I needed it for a cryptography protocol that I came up with. a paper that I never got around to writing called Logarithmic Zero Knowledge Spend from a Set for Generic Groups. Would be a pretty cool paper if I could find the energy to try and write it one day. Let it hereby be acknowledged that this is a sacred document protected by the power of the Fermat hexagon. Bind. Okay, next file. Maybe just stop trying to solve things and just, savor the chaos. Like last weekend. LLO responds. What was that? I just literally saw something in my background that freaked me out. Probably a bug. LLO responds, well, I have to say your company is unexpected. The premier algebraists of the whole galaxy, no? I was thinking of characterizing FFTs in terms of their two-adic index structure. Then I thought, why not regard them as functions rather than sequences? Then we might end up mapping the two-adic interval to complex numbers. Which would be weird, right? Or kind of quantum mechanical. I haven't got much to say about that file. Okay. The fourth file, I thought I had solved the heptadecagon formula, but then I fiddled with it and realized I was wrong. If anybody knows how to derive the heptadecagon formula using non-exponential, better than exponential computations, I'd be very interested. I've been thinking about it for 3 or 4 years, on and off, and I still haven't worked it out. I know how to, in principle, compute it. It's just it would require kind of exponential operations, which is not a very good formula for doing it, especially if you wanted to upgrade and find the formula for the 257-sided polygon, which is the next Fermat prime up, or the formula for the 16,537, or is it 357 sided polygon, which is the largest known Fermat prime, I believe. Anyway, thanks for watching. Like, comment, subscribe, etc. Communicate in any way of your choosing. Bind.